Every glass of beer poured today represents the latest iteration of a 13,000-year-old prehistoric science experiment. By definition, beer is any alcoholic beverage made specifically from fermented cereal grains, the edible seeds harvested from certain species of grasses. The earliest evidence we have of this brewing process dates back roughly 13 millennia to what is now modern-day Israel. Getting from harvested grain to a drinkable pint is a complex hurdle. Transforming raw seeds and water into alcohol requires navigating a highly specific two-stage microbiological reaction. Ancient humans managed to engineer this complex biochemical process thousands of years before they even knew microbes existed. Cereal starches must be chemically severed into fermentable sugars. Ancient brewers in China and South America's Andean region chewed raw grains. Saliva's natural enzymes acted as biological scissors. Meanwhile, Middle Eastern brewers soaked grains, triggering germination to internally release similar starch-breaking enzymes. Despite total geographical isolation, different human populations converged on drastically different biological hacks to achieve the exact same chemical prerequisite. Once they had a sugary liquid, they needed to execute the second step, fermentation, the process of converting those sugars into alcohol and carbon dioxide. At the time, no one added a specific ingredient. Instead, microscopic wild yeast spores drifting freely through the air simply infiltrated the exposed vats. Because brewers often boiled the initial mixture, this imperfectly filtered brew killed off harmful microorganisms. Packed with fiber, B vitamins, and protein, it served as a safer, life-sustaining alternative to frequently contaminated local water sources. We can see how highly the ancient Babylonians revered this brewing process on the Code of Hammurabi stele. The legal text carved into this stone actually mandated daily beer rations for every citizen and prescribed the death penalty for any brewer caught overcharging. As production later shifted to large-scale monastic brewing in the European Middle Ages, brewers moved toward the addition of hops. These acidic green flowers provided a distinct bitterness and acted as a natural preservative. Because the microscopic mechanics of yeast remained completely invisible, humanity protected and propagated this vital biochemical reaction through strict laws and religious reverence, rather than scientific understanding. In 1876, French chemist Louis Pasteur provided the missing biological link to this ancient puzzle. Pasteur became the first person to formally identify yeast as a living microscopic organism, proving it was the sole biological engine driving beer fermentation all along. In this cross-section of a modern fermentation vessel, visibility brought control. Brewers cultivated yeasts thriving in colder temperatures that gather at the bottom, producing crisp lagers. Conversely, strains thriving in warmer environments rise to the top, driving quicker cycles yielding porters, stouts, and pale ales. While laboratory precision now allows producers to extract alcohol while preserving flavor for modern non-alcoholic varieties, some brewers actively reject that control. Traditional styles, like Belgian Lambics, intentionally revert to those ancient methods, relying entirely on the spontaneous fermentation of wild airborne yeast. Whether crafted in a high-tech facility or left open to the breeze, every modern glass of beer is the direct culmination of humanity's longest-running, collaborative science experiment. It is a process that directly connects prehistoric survival instincts to the foundations of modern microbiology.